All right, thanks everyone for attending today's webinar. If you have called into the audio, please keep your line muted unless you want to ask a question. And Susanna, you can go ahead and get started.
Okay, thank you. So thank you and welcome everybody. So in this webinar, we are going to introduce the model of the Data Discovery Index, which is called DATAMED'S by the bioCADDIE consortium. The model name is DATS, and we will walk you through the detail and also explain you how we have developed it and progressively annotated with schema.org. Also tell you what the next steps of the work are going to be. I'm going to share the presentation with my colleague Alejandra and Philippe, and this first slide also serves as an acknowledgement to the core bioCADDIE team, to the PI, Lucilla, and the co-investigator. So first of all, slide number 2. Yes, this is an outline of the webinar, which is being recorded, and both slides and the recorded will be posted on the bioCADDIE website. So I really want to give just a quick overview of what bioCADDIE is and what that role is in the DATAMED prototype for those that are new and they've called in, and also introducing what the scope of the webinar is. Then I will hand it over to Philippe and Alejandra, who will walk you through the development process, where we are now, and what are the next steps. And then hopefully we have 15 minutes for questions. Although we do realize that for some of you, there might be a lot of information and you might be new to the activity, and perhaps you would have to digest the model and review it at your own pace, and we will also explain how to provide feedback. So, next slide. Right, okay, so what bioCADDIE is tasked to do by the BD2K consortium is to create DATAMED, which is meant to do for data what PubMed has done for literature. So DATAMED is a data discovery prototype, and I want to stress the word prototype. The scope of the DATAMED is to help users to find data sets of interest to them and access them, and knowing how these data sets and the related data can be accessed. The scope of the DATAMED as a prototype, and then in the future as a production system, is also to interoperate with what is called the NIH Commons, which is this concept of having all biomedical digital assets, so not just data sets, but software, standards, and everything else accessible and connected. So datasets, it's also following the principle of FAIR, where FAIR stands for fungible, accessible, interoperable, although DATAMED will mostly focus on find the data sets and define accessibility to those data sets, therefore to the S and to the A, actually part of the principle. So in this webinar, we are not presenting the prototype, but I do have to briefly explain what the DATAMED, the prototype, is meant to do in order to provide you some context with the DATS model and why it has been developed in a certain way and it will need to be continuously developed in a certain way. So DATAMED as a prototype needs to be designed as an element of an existing ecosystem, meaning data sets already are available in certain repository, and DATAMED is not meant to replace existing repository, rather serve as an aggregator. And this activity, although the prototype is developed by a core team within bioCADDIE, we have also a series of pilot projects running that complement the activity of the core development team, because there is a lot that needs to be done. Now, if you want to know more about the general scope of bioCADDIE and this vision, I really need to refer you to the white paper, which is available from the homepage. May I ask you everybody to mute, please? There is some background noise. Thank you very much. Okay, so this is another slide illustrating again, giving some overview of the prototype, which is being developed within the bioCADDIE consortium by the development team led by Jeff Brett at UCSD and Hua Su at University of Texas. The reason why I wanted to really show it's especially to illustrate the needs that the prototype need to have a model which is designed for representing the metadata and developing ingester to extract the data from existing repository. And that's why the searching interface and so on and so forth. So if you are interested in accessing and viewing the prototype, the current prototype, the DataMed, from the home page, you will have access to it. And I want to stress the fact that the current version you will see it's not yet based on the latest model, reason being that the two activities are happening in parallel. Now, from now on, we are going to focus indeed on the model that underpins the DataMed. And to access all the information that we will present, it's quite simple from homepage. On the right-hand side, there is a link to metadata standard. If you go there, you'll find all the information about the DATS and the link to the latest specification, which is available as a Google document for an easy way to provide you comments, and as file into the GitHub, and will soon be pushed in the node, so they will be citable. Let me start you from saying what DATS stands for. The reason why we're choosing this name for the model is because the DataMed has to do for data, what PubMed has done for literature. And in PubMed, in order to be indexed, journal they provide a JATS file, which is a journal tag article suite. And I guess similarly, we can think of databases to provide a data tag suite in order to have a scalable way to start indexing the different sources in the prototype. Okay. So generically, bioCADDIE has several activities happening because there are many things that need to be tackled to develop the prototype. So not just, of course, the model, and everything is done engaging with the community. And that's the reason why it is important for me to show, first of all, that several people have participated to the development of the work which is being presented, not just the core team, the core developer team in bioCADDIE, but also the members of the working group number 3, which is the metadata working group, so-called, which I chair, and the working group around metadata for accessibility to the data set, which is chaired by George. So many people to acknowledge. So going straight to my last slide, before I pass over to my colleagues, what the scope of this webinar is and what the key points are. We are going to walk through the latest specification called version 2, which is, as I said, it's available from the bioCADDIE page. And describing both actually the creation of the model and the latest work and the next step. This webinar is also quite important because in June, 23rd of June, at UCSD, there is a workshop where repository maintainers and developers have been invited to attend and look at the DATS model and see if and how this actually can be easily mapped to their existing model, and therefore if the DataMed will be able to extract as much as metadata information from these databases. It is also important to say that what we are presenting here is work in progress, and especially after this workshop, we are going to review the material based on the workshop attendee feedback, on the feedback of all the community, of you participating, and of course of the DataMed core developer team, because they're writing those ingester. And only by testing the model we can know if this is working or what needs to be changed or how can it be improved. Okay, So in the next part of the webinar, I'm going to hand over to Alejandro first, which will walk you through the development process, and then to Philippe. And just to remind you that this webinar is recorded and all information will be available from the website.
Okay, hello everyone. I'm going to tell you about the DATS development process and how we came up to version 2, that is the one we are presenting today, and the main elements of the model. So as Susanna mentioned, the DATS was developed to support the capability of the DataMed prototype to allow to inject the key metadata descriptors from the different data repositories that are being considered for the prototype. So the main entities we consider are information and relationship between authors, data sets, publications associated with the data sets, the funding sources, and the information about the data types and the biological signals that are being considered in the different data sets. So the development process that I will mention a bit more is related to gathering different use cases and compensative questions, and those allow us to define the boundaries and levels of granularity of the different entities required to answer the different queries. So we followed a twofold approach, considering the set of competency questions. You can see a few examples here. But not only that, but also existing models for existing repositories, which are all collected in BioSharing website. And these allow us to define the model, which is currently serialized as JSON schemas, and we have mappings to a schema.org. We will expand this on this webinar. So in terms of the use cases, there were several workshops. Also, the use cases were collected through a white paper. They were submitted by the community from NIH in general. And this allowed us to identify the key metadata elements, which we bin in different types, such as materials, processes, information, and properties. So this binning helps us to identify the main entities that are required to answer the use cases, and these entities are the ones you are going to see in the model overview. As I mentioned before, in addition to the use cases, we also consider existing metadata schemas, such as schema.org, DataSite, RIF-CS, the W3C HCLS dataset description specification, that in turn considers several other vocabularies related to describing datasets, as well as, so those at the top are the generic models for describing datasets in general, but we also consider more domain-specific related to life science models such as ISA bioproject biosample, and going into more specific technology-based datasets like PRIDE, ML, MageTab, and other models. As I said, all of them are listed in a BioSharing collection. And also, you can see this mapping is available through the specification as Appendix 4, and you will be able to see how we mapped the different models. So in terms of what metadata descriptors to choose for the model, we know that there isn't an ideal solution. So we know that there are many databases that won't have all the metadata elements required to answer the use cases, for example. And equally, some databases will have more information and more detailed metadata that's the overarching elements that we considered. So those are things we had into account in the design of the model, and we will show that we, for example, consider an extension mechanism as well. So what we will show you today is the version 2, that is the result of several iterations of testing the model. both from the two perspectives I mentioned, so the use cases and the mapping, but also through the ingestors and the current prototype, and how we could answer the questions with maximum coverage, but considering the minimal number of data elements. So the model description that you can find as well as a spreadsheet in an appendix, you will find that for each metadata element or entity, we include the different properties describing the entity and a definition for each of them, both entities and properties, as well as what are the values expected for those properties. When available also in the spreadsheet, you will find that we link back to the use cases and mappings that make the entity or property relevant. But also, we found useful to distinguish between a core set of entities and an extended set of entities, given that the core ones are generic and applicable to any type of data set, and it would be the equivalent to JATS for the description of journal articles that can describe any type of publication. At the same time, the use cases have many elements that are very domain-specific related to life sciences and biomedical data sets. So we also consider these extended elements that allow to support these use cases in life, environmental, and biomedical science domains. And in turn, it could be further extended, and as I said, we will mention about the extension mechanism. For each of the entities, which we consider not mandatory in both the core and extended set, and they will be used only when applicable to the dataset being described, but we identified very few properties that are defined as mandatory. So if the entity is available in the description, we expect to have at least those entities. We will show in a diagram that this is being really a pragmatic approach because only really few elements are definitely required. So in terms of the general design of the DATS and the scope, which data sets are we considering, we aim to cater for both experimental data sets, which do not change after deposition to the repository, and we actually provide examples in the GitHub repository for data sets available in dbGaP, in geo and clinicaltrials.org for this type of data sets. But we also covered data sets in reference knowledge databases, which describe concepts such as genes, whose definition morphs over time. And in the GitHub, you are going to find a DAT file describing a UniProt data set for this case. You will find as well that the dataset entity is linked to other digital research objects which are relevant and considered important within the NIH Commons, such as software and data standards, which are the focus of other discovery indexes, for example, BioSharing in the case of a standard. So in the DATS model, they are available mainly as a reference to information that will be provided in these other repositories. The spreadsheet I've been referring to related to the DATS model version 2 is available in Appendix 1. You can find it as well through GitHub, as well as you will find in GitHub the JSON examples for UniProt, dbGaP, Geo, etc., as were mentioned before. Okay, so in order to give you an overview of the model, here this diagram shows the core model, so only the entities that are available as part of the core model. And as you can see, these entities are really generic and allowed to describe any data set. At the core of the description is data set. And you can see that we support to describe different data distributions for a particular data set. Each distribution will be associated with a particular data repository, and each distribution will have a set of access modalities, which in turn will describe, for example, licensing terms, as well as authorization and authentication needed for accessing the data distribution. Additionally, a data set might be associated with a publication, with one or more publications. And in turn, both the publication and the data set may have an associated grant to acknowledge, and a set of people or organizations that are responsible for the data set and its distribution. In addition to these elements in the core model, we also indicate the conformance to different standards and the possibility of having dimensions of different variables within the data set, as well as software associated with the data set, so that might indicate how it was produced, for example, and the different material. In this case, we refer to mainly biological material, but could be, it's a generic entity that might indicate the different data types for the data set. So in this diagram, we are now showing you the properties that are mandatory for these entities in the core model. For example, you can see that within data sets, the title, the type, so these are the data types, and the creators are considered mandatory, while, for example, in the access information, a mandatory attribute is the landing page of the data distribution. As you can see, very, very few attributes are really mandatory, although if you see the spreadsheet describing the whole model, you will find that we do provide the option of many attributes for each of the entities that might be useful in different cases. This following diagram shows you grade the entities I already discussed in the core model, and shows the relationship with the entities we consider as part of the extended model. These are mainly all the processes, like, for example, data analysis, data acquisition, studies that may have produced the data set, and other generic activities, as well as, for example, treatment, different study groups, and different specific materials such as anatomical parts, taxonomic information, molecular entities that might be relevant for different data sets. But as you see, these are in reality more specific to different domains, such as also, for example, the indication of a data set relevant to a disease. So that's why they are part of the extended model. So following on and explaining a bit why each of these entities are important, we found these rules of thumb in terms of dividing the entities in what, how, which, where, when, and who. In the case that, for example, what is the data set about, it is usually relevant to describe the material that the data set is describing. How the data set was produced and which information does it hold is relevant for entities such as data set and data type. Data type, in turn, it contains information, methods, platforms, and instruments that are relevant for that particular data type. And then we have different events or processes such as study, data acquisition, again, that explain how the data set was produced. In terms of when it was produced, where it was produced, we have the information about the distributions and access, as I mentioned before, that again has information about the licensing terms. When we describe it through an entity or date that allows to specify the type of date, so creation, modification, start and end date for processes, so timestamping the different events and entities, and who we support the description of people and organizations and their roles in the data set, the funding, and the different processes. So now, and this is really relevant for the workshop on June 23rd, we are working with the community in identifying different guidelines in how to implement that, and which are the different curation guidelines for the data repositories that might be interested in implementing that. One of the very important points is identification, for which in that we support the data site approach in having identifiers, related identifiers for the primary object, related identifiers that point to related or secondary resources, and alternate identifiers that are aliases for the resource. So, as I said, these guidelines are being produced, and we take into account recommendations done by bioCADDIE working groups, such as Working Group 2 for data identifiers, but also community work, such as the simple rules for persistent identifiers in life science data. Continuing with the guidelines, and to give you just a flavor of the things we are considering, we are working on providing recommendations on how to support, how to report citation information. So in the case of published work, it might be enough to provide the identifiers for PubMed and DOI, for example, one or the other, or both if they are available. The implementation then might rely on APIs to pull the necessary information for indexing or search. In the case of unpublished work, we have different options. That is to identify the title, the type of the publication, and the publication venue, if available. And for example, we have different options to identify the authors, as different repositories might have different elements. Some of them might have author lists, and in other cases, the authors are identified as different individuals, where we can point to actually first and last name. So we provide the different options so that different repositories can include the information they provide. As another example of terms of implementation guidelines, we are considering to make really clear the distinction between dataset and distribution. And for that, the UniProt example that is available in the GitHub repository shows exactly this, where there are several distributions, for example, in XML, RDF, XML, and HTML, and there is other distribution like the FASTA file information, which is not the total description of the dataset, but it's a partial information. So those we allow also, the DATS model allows to specify this relationship between the dataset and the distribution. So as I mentioned before, one of the requirements we found in the iterations of the model was the need for allowing extensions to the different attributes we described, as we cannot really cover what all the potential data repositories cover. So for that, we created an entity that is called category values pair, in which simply specifies a category that might be associated with an ontology term, for example, or a URI, and it might be associated with a set of values that, again, each of them could have an ontology term. So basically, the main point we want to convey by giving these examples of implementation and curation guidelines is that it's something that is work in progress, together with the core development team that has actually implemented the DATS in previous versions within the prototype. So we are working in implementing an extended DATS considering those guidelines and the metadata review done by the ingestor's work. So now I will pass the lead to Philippe, who will present the work on schema.org.
Hello, good afternoon. So really, just get to the slide. Yes, this is recent development that we have been performing, working for in the bioCADDie work group. Simply owing to the kind of buzz around schema.org, and we wanted to know what would be the benefits of exploring the model and see the amount of coverage that this would provide and why would we do this. So of course this is the key question. Owing to the fact that schema.org is being developed by the search engine consortium, which brings together Google, Yandex, and Yahoo, for instance, that would be a kind of easy, possibly low-hanging fruit. At the same time, the immediate benefit that we could have by integrating with schema.org is any data present in the DataMed could be also searched through the Google search engine, for instance, natively once the DataMed has been indexed by the popular search engine. So in terms of data discovery, that would also probably bring more people to the DataMed through common interfaces. So what we have done is that, of course, consulting schema.org and the extensions, because there are different components. This is a very dynamic environment. There is a dedicated GitHub repository for schema.org that allows people to forward their use cases or their requests. And basically this gives a kind of framework for the development. Also, as mentioning the buzz around schema.org, there is a European initiative under Elixir, which is called bioschema.org, and basically that allows, that attempts to somehow create its extension to the current schema in order to provide and support and cater for a number of use cases identified by the bio community. And this is also a kind of in a bigger framework, a global interest to the NIH Common, and the different working groups that are actually powering the research. So this is basically a screenshot of the initial work that we've been doing, and then we used Google Spreadsheet to perform this kind of manual mapping, which is fairly laborious because we had to do this kind of lookup into the schema.org from their side, and then slowly make our way to identify the relevant elements. So we did this in double blind, in 2 rounds of independent review, so that we could discuss among ourselves, okay, if the mapping could be reliably and made in a sound manner to see the kind of overlap we would get. So now we've got about this document. But also I wanted to mention that this is not entirely new for the bioCADDie working group on the metadata DATS to have had a look at the schema.org. In fact, as Alejandro mentioned, we have reviewed a number of models before that, and we had a first shallow pass at schema.org in the previous document, and this is what you can see in this appendix that is also released as part of this seminar. And basically that shows the kind of scan that we performed before creating the DATS. So, of course, having a Google document with a mapping is one thing, but it's probably much more interesting to have a machine-readable output, and this is basically what we produced in the form of a JSON-LD context file, which is a stepping stone for us to move away or to convert what the current representation in DATS, which are JSON schemas, into creating instances which would be compliant with the JSON-LD, and we have the ability to really interrogate the documents using schema.org elements. So this is available from the GitHub repo. You will be able to dig into more details into this element. So now I will give you kind of feedback about what we found in this work. So that in a way we can find some kind of decent coverage, but roughly 80% of the data entities and properties have been mapped. But the alignments between the schema.org entities is a bit coarse, and we lack specificity and precision, I would say. But also we found that there were major gaps, which represent about 20% of the total count of entities, but these represent really key information that really matter for most of us. So there is no clear cut for information about species and taxonomic information. And when it's available, it's restricted only for infectious agents. And by default, the species that you can talk about is only Homo sapiens under schema.org. So again, immediately we have a massive gap. And again, similarly, for molecular entity, there is no notion of DNA, RNA, protein, or chemical entity. We have substance and things like drug, but again, that gives high-level container, but again, we would miss specificity. Then, of course, anatomical structure is again missing. We have no notion of plant or animal or environmental matter in that sense, except unless we rely on substance or the different taxonomic information related to human. There is no notion of biological process or biological entities. Again, that's a shortcoming for the DATS. Additionally, as we pointed out, the DATS contains two elements, the core and the extensions, and the extensions really allow you to have a more granular view and representation of elements revolving around study and study design and variables and things like that. And what we found out is that dimension and variable is absent from schema.org. So that's again something that we need to address. And also the other finding is that anything related to study in schema.org is essentially related to medical or possibly clinical trials, which immediately rules out a huge swath of knowledge in the field of biomedicine and biological investigations, which in a way would be definitely missed by the DataMed discovery engine and the purpose of this activity. So moving on, what we also have identified is shortcomings in terms of how to really specify or clearly identify a data model, or specification, or data standard. There is obviously something called media object or digital document, but again, the specificity is a bit wanting, and I guess that this is the kind of effort or interaction that the DATS, the bioCADDIE, and schema.org could have in the future, and this is a kind of ongoing discussion that we working with the project as we go along. On the minors, more, well, again, that's important for the use case that we've been working on. The clear identification of grants, funds, and funding agencies is lacking. We found a property called sponsor under the schema.org that would allow to point to an organization, but this is, again, a bit convoluted or not immediate, I would say. Then these are, the remaining points are very detailed, more granular levels, which we can discuss further, but this is, in the time remaining, I think we can focus on the last elements, which essentially deal about the next steps, which is to continue the discussion with schema.org in terms of how we move to the JSON-LD serialization, continue the engagement with the group and the Health Lifelines schema extension, and of course work with the bioschema group under Elixir to see how this dialogue can be maintained and whether this is the best route. There are many other potential elements or resources in life science covering semantic support, and we need to test which one are really optimal for the use cases that we need to treat. So this will be done in an iterative manner with the people contributing to the development of the DataMed core. And again, we will be going back to the group and work with them to figure out the best way to produce the dataset ingesters and bring them up to the latest specification versions. So that's the main goal. And of course, we have this important workshop at the end of June, where all this will be really the best opportunity to really discuss issues and evolve again or refine the model as we have it so far. So just a last thing, as you can see, that all the information will be provided from the homepage of the bioCADDie project. And for those who have missed the seminar, this is being recorded, so you can go back to the content of this of all the information that we've presented at your leisure. And I will stop there, and we will take any questions from the audience. Thank you.
The conference has been unmuted.
Yeah, hi, this is Phil Bourne. I just want to first of all congratulate you on this. This is clearly lots happened and it's really good. I just want to understand a little more about how something that's done in DATS, the process by which ultimately that gets mapped into or becomes part of schema.org. You have these other groups like bioschemas.org. What's the process? You propose something and then it's considered, and then how does it sort of become part of the standard, and how long does that take?
So thank you, Phil. This is Susanna. So actually, we have had several meetings. The latest was during the 4C11. There was a data hackathon that Ian Forrest, as you know, from B2K, and Raphael from the Elixir side and bioschemas organized. We had also another previous face-to-face meeting where we had the schema.org representative, specifically Dan Brinkley from Google during the Elixir All Hands meeting. And that's exactly one of the things that we discussed, how the feedback will come. Now, of course, schema.org has everything in GitHub, and there is a tracker. So very clearly, the way to do it is to go through the tracker and the formal process of explaining why an element needs to be added. And the schema.org core group will also evaluate and discuss if this is an element which goes into the core schema.org or has to become an extension. But we also learning the process, indeed, how to, because there is, for example, a group called Health Life Science Schema.org, which you can see here, and we have Mark. I don't know if Mark is on the call. I'm looking through the names. I don't see him. So he is at the chair of this group, which is extended schema.org for more health. It's got a more clinical trial focus. And we also have a working group and etc., which again communicate closely with the schema.org. Now, the bioschemas.org, and I'm looking to see if Raphael is on the call. No, it's pretty similar here that you bring together people that think that there is a need of extending it for certain area. So under the bioschemas, for example, we had more bio-oriented essential, but not necessary. For example, we are extending, proposing essential for training material, okay, which is not necessarily bio-specific. So the point is, as we gather, the community gets together, and if you have the critical mass of what needs to be done, you review first what schema.org has, and then you propose the additional elements. And schema.org also has documentation of how you need to reuse what they have and how you propose the extensions. But the closer engagement with Diane Brinkley and the schema.org group is helping us. So I'm sorry that's a long answer to your question, but it's a work in progress with other groups that, like us, want to do this extension and engaging with the core.
No, I appreciate it. It's good for me to understand that process more. I mean, it's a balance between wanting to be standardized and how fast you can work. And it seems like it's working for you as far as I can tell. So that's the main thing.
And that's a very good point, if I can pick on that. That's the reason why somehow going through the process of developing the DATS as a model to see what the needs are, and then mapping back to schema.org to see what the missing elements are and how the extension can be done, has allowed us indeed to move on and create a model which still fulfills the requirements and enables the prototype to be implemented. Otherwise, this would have not been possible.
Yeah. Great.
Could I follow that up, Susanna? This is Carol.
Of course, yes, please, Carol.
Hello. Yeah, I also want to follow up what Susanna said there, because we have also met with Elixir and with Susanna's team in London at Google HQ. And we had a meeting there with Dan, who's head of schemas.org, and Natasha Noy, who's head of datasets. And at that meeting, we identified an action plan which has 6 activities in it, 3 of which Google are going to help us lead, which includes extending schema.org in the direction of samples as a first step, because samples are absolutely critical, and we think there'll be a major discovery point for datasets. And I've started a bioschemas.org group for data as opposed to training materials, which once I've mastered the website will be available for anybody else to join, and we'll be picking that up with key Elixir datasets, and that would be an open activity. That is much more along the lines of actually directly working with the schema.org folks, and in fact I've been made a GitHub contributor to schema.org, so that's actually impacting them rather than just passively mapping to it, in the same way that the FHIR group are also affecting schema.org.
Can I add something? This is Natasha Noy from Google.
Oh, there she is.
Yes, I am.
Yay.
So
it's all true. It's all true, Natasha.
Yeah, so everything that Susanna and Carol said are correct. So from the sort of schema.org and Google side, I just want to add that Dan and I have actually spent yesterday trying to file a few new bugs on the GitHub sort of how to extend the data set definition. So we're definitely working on it. We welcome feedback. The GitHub repository, I know like Rafa and Alejandra and Susanna, they all know where it is. It's fairly easy to find. It's a public repository. So we would like to sort of have you contribute to that discussion, but the idea is that we will put it sort of as a sample example and then pending. Hopefully reasonably soon. It's not a terribly difficult process to reach agreements on this kinds of things. So it should be moving reasonably quickly if there is enough interest on the community side, and there's definitely interest on our side.
So this is Phil again. So this is great. It's one great hug fest. I love it. I guess the sort of question for me is, for myself to know the answer to is there good alignment with, it sounds like there is, between what's sort of happening on the BD2K side and what's happening on the Elixir side when it comes to these, essentially this representation?
Well, I don't know if the question is for me, but I would say probably my answer would be yes. And thanks to Carol and Natasha to fill my memory gaps. So actually, Phil, that's what we had in this slide, that the bioschema.org is also now Elixir supported a bit more properly. And then actually, I would say yes, there is an alignment. And I think what would be useful, Carol and Natasha and everybody else involved in this, that we try somehow to summarize the status, because as I said, if I try to make a summary of what's happening, there is so much happening. It would be nice to have like a status of where we are and all the discussion for people that ask, and particularly for people that want to be involved.
Yeah, that's why I've suggested that we have a data group for bioschemas as a way of channeling life science extensions to the schema.org. And I have actually I've created that group, so I'll distribute that. That could be a mechanism. Then we're channeling it through the bioschemas.org activity.
this is great, Carol, but we do have a group, actually, because the DATS is already part of the bioschema.
Oh, yeah, that's true, but...
We just have to activate that to merge not just what we do, but all the different discussions that we are having. And because what Alejandro Philippe just presented, the alignment and all the gaps we've identified, and this is work, done, up to yesterday, we're going to even summarize this into the bioschema, so web pages, so that everything is updated and in sync.
Right, good.
The only thing I was getting at is if the NIH/BD2K, I'm all for maximizing the collaboration with Elixir in any way possible. So if that needs some kind of tweak at any time, don't hesitate to reach out. But it sounds like it's on track.
We will definitely take up the offer, Phil.
Yeah, I think it would be helpful. Actually, the main thing that we next need to do is to bring in some data sets from Elixir, which is what we're planning to do. We have particular interest from the marine metagenomics guys, which has got nothing to do with healthcare, but I think that will be an important point. And then once we flipped a couple of major data sets, then I think we'll be home run. And the other piece that I think is very good, which I presented the work package leaders meeting at Elixir at the end of last week, was about the value of using schema.org for citation. And Jo McIntyre, who leads the data platform of Elixir, is totally bought into that and was very vocal in her support, which was terrific. I think that also flipped a number of skeptics in the Elixir family to the direction of schema.org. So that was a great thing there.
Sounds great.
We might have scare off other people to ask questions, but please, we have 10 minutes. It's great because we managed to squeeze a lot of information in a shorter time because we do want to have discussion. So please, questions.
So if you flip back all the slides, then I'll remember the question I had somewhere around slide 17. But I wouldn't actually do that. I'm wondering when the slides will be when and where it'll be posted. It's not on GitHub or the webinar site yet, is it?
School. I have what may be a naive question, but in regards to the core elements and the extendable elements, I'm wondering if there was any thought to being able to have a core schema definition and an extended schema definition. And the reason that I'm thinking that would be if you have a particular experiment type, you may want to say for this particular core experimental type extended schema, it has additional elements that are required that are not required in the core schema.
That's a good point, and I wonder if I think this would be easier to do and will inform us on how to do correct during the workshop or at the workshop. I'm sorry, I don't know who raised the question and if you are participating to the workshop, because that could be something you could bring it up. Do you plan to attend the June 23rd repository workshop at the bioCADDie, UCSD? Oh, can you hear me?
Susanna, this is Ron. The workshop will be June 23rd. The full public release of DataMed 1.0 will be about June 30th. So I guess there'll be some development that will have to occur to incorporate bioschema.org later on in further iterations of DataMed. So will there be work with the core development team to incorporate that?
Of course, absolutely, yes. And I wonder if Jeff or who are on the call, they might say Jeff is on the call. So yes, of course, that's the immediate next step that we're going to do. And somehow it is happening because they have access to the model as we evolved it, and they've started doing already a lot of work. And Jeff, if you want to say anything, you want to add anything, please do.
Yeah, no, Susanna, as we had discussed in the past, it was really, looking at, one of the first steps once we have the schema.org mapping would be to implement, that markup, within, the prototype itself, so that we could sort of function as a sort of provider of the schema.org information for the data sets. And then there's also work with one of the bioCADDIE supplements where there's the data citation implementation pilot project where there's a working group on repository landing pages where we're also, working on, with repositories on working on what needs to be, sort of on a repository landing page as well, sort of the best practices for that. And that's a work group that's headed by Martin Fenner and Mercedes Crosis.
Exactly. Thank you very much for reminding that. Yes, indeed, we also have a call with them on Friday, and I see the team is also on the call in case you wish to add something. I know that you, Jeff, as well are involved in this pilot, this bioCADDIE pilot.
Yep. Right. I have nothing to add. I think this is going to be an important part of the ecosystem to be able to consume and construct data citations off of landing pages.
I have a question, and somewhat related. This is David Obenchain from the National Institutes of Mental Health Data Archives, of which NDAR is a part of. And I was looking around on your GitHub page, and I see that you have ingesters built for scraping data off of our landing pages for projects as well as for studies which are related to publications. And I was just wondering, what I don't see our repository listed yet in the DataMed pilot, and it looks like not all of the data has been ingested. And I was just wondering how we sort of make the connection and talk about doing that, and just interested in learning more about that.
Oh, this is great, and actually, thank you for your interest. And Jeff, I will actually suggest that you answer the question, please, given you lead the ingestion activity for the development team.
Yeah, it was hard for me to hear. This was for NIMH,
Yes, this is for
NIMH
Data Archives, of which NDAR is part of. We also have the our DocDB project, National Database for Clinical Trials in Mental Health, Pediatric MRI. There are a number of different repositories under that sort of umbrella, and we're, our repositories are under active development. And I saw a number of scripts written for ingesting data, and that was both interesting and also a little bit concerning because we are iterating on development and things change. And I don't know if the scripts that were run 3 months ago would still work as expected, and how those are being maintained and how that data is sort of being pulled. So I'm just interested in learning more about efforts related to that and how we can potentially participate.
Right. So I mean, the repository that we started with is NDAR, because that has that had the most content a little while ago. But definitely, we'd want to touch base further for some of the other repositories as we sort of broaden out the prototype.
Okay.
And you're going to be there in June, I believe. Is that or someone representing NIMH, if I remember the list correctly of the attendees?
I'm sorry, it's hard for me to hear because we actually have a fire drill going on right now. So unfortunately, I have to get up and leave. But
okay.
One of my colleagues, I believe, is on the phone though.
Yeah, I thought that there was someone from NIMH attending the June 23rd workshop, if I remember correctly.
And actually, if I can make a more broader comment on this point, Jeff, and hopefully Lucilla agrees with me, I understand there are two places for the workshop. So if we have anybody on the call running a repository and interested in the mapping exercise and discussion, please do go on the bioCADDIE website under events. You can see there is a workshop and you can register or contact the bioCADDIE lead for questions. And Lucilla, you correct me if that's fine.
Yes, this is correct. And also we have been able to secure some funding for people to come and learn more about the metadata and how to get it ingested. So please contact us on bioCADDIE at ucsd.edu.
Would it be okay if we sent somebody from Elixir?
I think it would be excellent.
I'll see if I can get somebody to come from the data platform of Elixir.
No, thank you. That'd be great. All right, so I hope to see you all on June 23 here at UCSD, and I want to thank the team for a great presentation, which is recorded and will be on our website.
Thank you.
Thank you, everybody.